Welcome to Classic Rewind. I'm here with Larry. We're putting the motor together. If you have any questions or comments, he's located in Hackettstown, New Jersey. I'll leave a description in the bottom if you want to contact him for any motor work. He's very knowledgeable in the LS3s and what other motors?
LTs, Pontiacs, pretty much anything with pistons and heads and cranks. Do a lot of pro touring, fuel injection, dyno tuning.
Okay, so I will. I'll put his description in the bottom. So I'll leave the information. I'll give you an email or something if you want to reach out to him. I'm sure he doesn't want to be bombarded with phone calls or anything like that. So, all right, let's get started. All right, we got a flywheel holder. So that way, when you're tightening down the flywheel, the crankshaft does not move. So that's pretty cool. All right, Larry's putting in the pilot bearing right now. Go ahead.
You want to make sure you use something soft aluminum so you don't damage the bearing or bushing. Make sure it goes in straight.
Okay. Yeah, that, and you said it flush, correct, with the crank?
Yeah, it's the hair out, but it's pretty flush.
Okay. All right. Perfect. I'll show you everything here. Got all the alignment tools, the gauges. We're going to be doing all that today. There's the bell housing and all the clutches. So I'll show you how we put this all together. All right, now we're getting ready to install the QuickTime bell housing. Lining everything up. We put the shield behind here, and we put the bell housing, and then we're lining up with the bell housing pins. We're gonna have to get extended ones and replace them down the line. See, make sure everything is lining up for the meantime. So just doing that. All right, be right back. All right, we're putting on the template to gauge the crankshaft, to dial in the bell housing, and the arm is in there to make sure. It's in the picture that
dial indicator is not fully set up yet.
Yeah, the dial indicator is not fully set up, as Larry said. So I'm just watching them bolt it all up. So, all right.
But I am going to need to get to your crank bolt now.
Crank bolt? I got to take that off.
Take that off. We're going to need to get to that.
All right.
And then we're going to remove the lock.
Okay. Let me do that for you. All right. We're dialing in on the bell housing to make sure that that's right.
We're going to check for the parallel of the bell to the block. It's tough with the T56s as there's no true circle to follow with all the cutouts, and plus with the powder coat it's going to be off a little bit. We're going to give it a shot, see what it reads, note the measurements, and make a determination thereafter.
All right. All right, let's get to going. Yeah, we're just torquing it down to get it so we could get the bell housing adjusted.
Just check it.
Where are we at, 0, Larry?
Yeah, it's still relative.
Okay, and then we're just going to go around the bell housing and see how parallel we are, correct?
Correct.
All right, let's do that. Larry, let's discuss what you were doing here with the QuickTime transmission. So
you have one thing, you have you dial on your bell, but a lot of times, you know, you want to check your parallel of your bell to your block. If your bell is non-parallel with your block, when you go to dial it in, you'll have an oval hole, and regardless of what measurements you get, they're still going to be out. So what we did here, we set it up on the trans face of the bell, and then turn the motor over, and same procedure as dialing in the bell you would do, but you know, as you see, we have where the dial indicator is set up. Now, if you noted on the T56 bells, we don't have a continuous surface to run the indicator on, so you know, we are expecting, you know, a degree of error, plus the powder coat is on it. There's buildup there. So when we do these, we're looking for an outlier, something that's really off. You know, most times we do these, they're really good. They're a lot better than, let's say, your Super T10 or your T5 of, you know, the 80s, 70s, and 60s, or even earlier. These have been pretty good. But we did it. We've got a max variance of maybe 4 thou, and even when we started at 0, we ended at a -2. You know, just from moving the indicator to get over the cutouts from the bell, you know, that's going to disturb our arm movements in its relative position. So between the powder coat, that you know, we're a couple thou. We'll accept that as it is. I don't believe it needs any shims. But should you get something that has, you know, say a 10 thou variant, I would definitely look into that. You might need shims at that.
so when you say shims, it's like thousandths of an inch, correct?
Yeah, we got shim kit. Yeah, Jody's transmission, so it's this nice shim kit package.
All right.
And you got a whole bunch of shims in here.
Different thicknesses, I'm assuming thousandths of an inch to...
Yeah, you can go from 15 thou to 12 thou.
Okay.
And then we also go way down to, this is 1/1000th of an inch shim.
Wow, that's super thin.
Super thin. And you stack them up as needed. We've had some that, you know, the older bells that warp, and they can use 20 thou shims. You know, depends on a lot of
Variances. Yeah, the powder coating, if you have a dirty block, if you're putting this on an older block and it's been used and abused, so to speak, correct?
Correct. I mean, it's just some. You could have just, it wasn't torqued down right one time. It's a ton of variables. So we always check this out. And then if this is happy, we'll proceed with the dial in. Make sure the crankshaft can be in line with the transmission input. But otherwise, you know, you have a non-parallel bell, you're going to have an oval hole to do your dial in, and, you know, it's, you know, garbage in, garbage out. So
Okay. All right.
that's
so
it.
Let's get going. Sounds good.
Right there.
Wait. Okay, I see the numbers you wrote on there.
You started at 0 as you turned it. You can do it every 90. I like doing every 45. Because you got 2 people, it's easy. I go 0, 0. We're at 2. And we jump over here to 7, 9, 8.5, 5, and 2. So that's telling you that, you know, the bell needs to move. Bell needs to move up, you know, so you take this number, the difference, so you have 9 thou, you divide it by 2, so we got, typically you're low, but 0 minus 9, so you're -9, take the absolute value of it, and divide 9 by 2, then you get 4.5, 5 thou is the accepted tolerance. 4.5 is less than 5. Therefore, Harry is okay.
Oh, so I'm 4.5. Okay. All right. Wow. Okay. You want to do it again just to make sure?
We'll do it a second time, just to confirm some numbers. Absolutely.
Okay. All right. Good. So let's do that. What is that? Loctite? Okay. All right. We're setting this up. So we dialed in the bell housing. That's all ready. So now we just have this to put on, measure the pins so we could do the transmission.
Air gap. Yeah, throw out bearing air gap.
Throw out bearing air gap. That comes next. So here we are. It's looking good. Be back. We just got done torquing everything down, putting the clutch plates in. Bell housing's all secure and dialed in, so that's ready to go. So now we are figuring out the distance. What's that?
Air gap.
The air gap from the hydraulic throwout bearing.
To
So
the clutch pressure plate fingers.
to the
You want
clutch.
an air gap. Typically we aim for 160 to 200 on a single disc. On a multi-disc clutch, we can be up to quarter inch or 250. So we'll see what this starts off with, no shims, and then we'll shim accordingly.
All right, perfect. And there's the tranny, and we're setting everything up. So once we get everything ready, I'll turn the camera back on to figure it out. Okay, we bolted on this plate to the transmission, which aligns the Hydromax throwout bearing.
Expensive throwout bearing.
Expensive throwout bearing.
You can also use a standard GM1 from an S10 and everything else, and they'll work just as fine.
Okay, all right. But we don't have another one, so we're going to use this one, correct?
That's correct.
All right. So now we're going to measure out the distance from the arms on the clutch.
We're going to be measuring this distance here to here. We're going to measure that distance.
Okay.
And then we'll come over here. And then we're going to measure the distance from here to here. And then whatever that is, we're going to shim this out or maybe not shim it so we reach our appropriate air gap.
Okay. The tolerance, that's 160, you said, something like that?
Yeah, anything up to
150?
200 is fine.
Okay.
150 to 200, but you know, some people like the clutch off the floor. Some people like a one midway. The bigger the gap, the higher the pedal's going to release.
Okay.
And the pedal travel. The clutch is going to release and the pedal travel.
All right. Perfect. Let's get going. All right. We're going to measure this first.
Yeah, you're going to have to hold that.
Okay. Oop. You're just making sure it's equal all the way around?
It will never be equal.
Oh. Oh, because the arms are...
None of these are all even, so I'm just trying to just take an average.
Oh, okay.
Do a 4.7 to 5.77, and or we might do something like 5.2.
Okay.
You don't want to rely on the highest one because that's not truly accurate. You don't want to rely on the lowest one. So I'm just trying to see, you know, where some of these guys fall. So we're anywhere between 2.477 and 2.577, and most of the averages are 2.52, 2.5. I said 4.8. So we'll probably aim for like 2.520.
Okay.
for the distance to here. Now that includes the thickness of this bar, but we're going to carry this thickness over to the other measurement, and it'll cancel out.
Okay. We got done putting in a 6/1000 of an inch shim behind this plate here, which pushed this out to get it as close as possible to the tolerance that we needed, which is 150. So the 6/1000 of an inch is behind this plate. It's round the circumference of this, the diameter of this black plate here. And then we ended up putting 5 shims back here. So let me show you that. So we got 1, 2, 3, 4, 5, and that is 9/1000 of an inch each shim. So we brought it out to the specs that we needed to be within the powertrain tolerance. So when we measured from here to here, I don't recall what Larry had measured, but we came out within that tolerance of 150, 155. So I am actually very happy with the way that turned out. He had to run out, so I am actually finishing this video. So that's pretty much all we had to do to get it set up. So the tolerance between the tranny and the throwout bearing is perfect within the tolerance of the needles of the clutch here. And he mentioned that none of these are all exactly the same. So he took an average of a couple areas when he measured that out against this plate. And that's how he determined the distance that we needed to complete the tolerance schedule on the transmission. So that's it. I'm going to conclude this video. So please like, share, and subscribe if you haven't. And if you have any questions, please leave them below. And I will leave Larry's information at the bottom of the video in the description if you want to contact him and let him know if you have any questions or if you would like him to do some custom work for you. Again, his name is Larry, so reach out to me and I will give you his information. Finish up the video. The motor and the transmission are dialed in, so all we have to do now is make the tranny with the engine bolted fast and we should be complete. Larry had to run out, so I'm going to leave his information in the bottom in the description, or you can reach out to me with a comment and I will give you his information. I think I'm going to do that. Reach out to me, leave a comment, and I will give you his information if you're interested. That way he's not bombarded with a whole bunch of emails and comments like that. So he actually has a shop down in Hackettstown, New Jersey. So again, if you have any builds like this that you want it to be all dialed in, perfect, exact, let me know. I will give you his information. Other than that, I'm going to finish the video. I just wanted to put that in there for you, that information. So the motor's done, the engine's done. So all that needs to be done is bolted together, put the oil in it, and we're ready. But as you can see, we have a lot of more work to do on the goat here. So I'm still going to be working on this. Hopefully by the end of the year, I should have it in paint. I still need to dial in some body gaps, make sure the hood is 100% the way I like it. I'm still working on the rear trunk lid, and I'm working on the door. I'm almost done with the door, and I'm going to be posting that video pretty soon. And also the trunk, I'm going to be doing the trunk. I'm going to do a custom bumper on the goat in the back, because I want it to have have pretty much the same gap reveal as the doors and the front hood. And the reason why I'm doing that in the back, which is going to take some time, is because the bumper is smooth and symmetrical to the fenders in the front. So I want that to be the same look in the back, but that's a whole other video. Anyway, thank you for watching. Thank you for subscribing. Please leave a comment and I'll get back to you. I'll get back to all my subscribers. So I'll be seeing you on the next one.